I'm going to install this 100 amp hour LiTime lithium iron phosphate battery onto a homemade e-bike. I'm going to build a 12 volt homemade e-bike. I'm going to test how far I can go with 100 amp hours, and I'm going to do a full review of this LiTime battery. So let's get into the video. LiTime sent me their 100 amp hour Group 24 lithium iron phosphate battery. They sent me this for free to do a review, so I'm going to give my honest opinion on this battery. Thanks a lot to LiTime for sending this out. I really appreciate it. It's the same size as a Group 24 battery, and I have one here. Now this one here is a lead acid Group 24 battery. The lead acid battery weighs a ton compared to the lithium iron phosphate battery. £22.1, so it's 22 pounds this battery weighs. Let's put the Group 24 lead acid on here. This thing's a beast. Okay. Almost 40 pounds. The 20 amp hour is 11 pounds. So 12 amp hour, let's see, about 7.5 pounds. 13.3, 15 amps on the clamp meter, 15 amps on the charger. The app is hooked up and I'm at 69%. 0 cycle time. About 7 minutes left. The battery is fully charged and I'm going to do a watt-hour test now. I want to drain the battery completely down. LiTime, they sent me the 3000 watt inverter because I don't have an inverter really big enough to do a load test. This allows it to be clipped onto something. It comes with the cables. The inverter is off, but if you're concerned about a spark, just use a bulb or resistor or whatever. Touch to the bulb. And then just touch and let it sit for a second. So now there shouldn't be any spark at all. Oh, that's cool. This is awesome. It gives me the voltage, 60 hertz, 120 volts. So we have 3 methods to check here. We have the remote, we have the app, and we have the amp meter that we can just times the amperage being used by time. So I'm gonna plug a load into this and get it going and check the time. Here's my load. I'm gonna put this in the house and turn it on. App is running now. The inverter on. 30. Okay, there it goes. The clamp meter, 32.3. And the app, 33.1. 432. 370 here. Big thanks for LiTime to send out the inverter. I'm going to do a full review of the inverter in another video. Okay, so I'm going to let it run and see how many watt hours we get out of our battery. The battery indicator dropped right down. It is going down 5%. See how far. Yeah, now it's really low now. Okay, so I got my time now. Charge this battery back up now. I'm going to do a second capacity test. I'm going to use a battery monitoring. This one uses a shunt, so it measures current flow. The shunt is connected to the negative of the battery, so the load is here. So this is where my inverter is going to connect, and then my battery is going to connect. So I just have this cable. Battery monitor is on. Okay, the inverter just went off at 96 amp hours. Okay, so I have a 100 watt lamp. 100 watt old school bulb in there. Okay, so we've got 1 bar on the remote. So it ran the heater for 3 hours and now it's running the light bulb. 3%. There it goes. Okay, so it cut out. It's not dropping down. What I'd have to do is put a smaller load to actually take it down even more. 2% and 98 amp hours. Okay, so I'm draining it down with a headlight now. It is getting really low. 99 amp hours and it cut out. The BMS cut out on the battery. There it goes. Okay, so on here, it's showing 1%. I'm going to build a 12 volt e-bike using this bicycle from the trash. I'm going to do a range test and see how far I can go. First thing I'm going to do is build up the bike. So let's go. This is looking good. Now, I need enough clearance for the chain. This will be the first test with wood, and I'm hoping it'll work. These geared motors put a lot of stress. Even on metal, I've seen it bend the metal. It is quite sturdy. I'm actually impressed at how sturdy this is. I'm using 2 storm ties to connect it in the center there. This is a no-weld project, no drill, so no drilling into the frame of the bike as well. The video is not about me building an e-bike, it's about helping others build something. I wanted it to be connected here, but of course that's not possible. The chain's going to rotate this way, then put the clip like that, so if it won't get knocked off. All right, so the chain is loose, but it's not a big deal because I can shim the motor up. So I'm just going to put this onto the bike. It's perfect. This was a free fine carrier. It was actually a child seat. This was a scrap bike. It was just in the trash. It was missing some parts. I always try to build a functional project. Maybe I'll put a crate on here. I don't know. A top of a microwave oven. I'm just going to cut some shims out of it. I'm probably going to need more. Yeah, it looks like I'm going to need quite a few. Volt controller. Oh. Alright, so it's pretty much the same as all the other controllers, but it's 12 volts. Under the throttle. Wires are so short. So I'm going to have to cut the wires anyway because these are the same plugs. Alright, for the wires, I'm just using some residential 12 gauge copper wire. I've just doubled them up. So doubled them up for the negative and the positive. So 2 12s, I think should make a 8 positive and my negative. When using solid copper, of course, it can't flex, so it cannot be on anywhere it's going to flex. Braided wire will be what's moving, so that's how I usually do that. And then I can use the solid copper, and that just runs to the back. It's been working on many of my bikes. I have lots of solid copper laying around, so I might as well use it. 2 to 1 cable, so I can plug the motor in. So a lot of people would say don't use morettes and all that, but this stuff will work. This is a homemade bike without any soldering, without any welding. That's the whole idea of this build. So that goes like that. As long as these copper wires aren't flexing, then I'll tape these up. Then we got to get the controller set up. They'll run some old computer cables. Now the wires, I'm just going to extend these. So I just have to connect my wires up here, so red, black, and keep them corresponding. Most multimeters have this option, so just put it on ohms, select the audio here. So when I touch these together, it's going to beep. What I'm going to go through these wires. So I'm going to switch the switch here. Let's see, blue and yellow. There, okay, so is yellow and brown. So those two are my switch wires. Perfect, I had enough wires in the cable. Push the switch this way, bike is on, and then it's off. On, off. I hope it's gonna fit. Yep, it fits no problem. Lots of room. I know all the comments about fuses, but there's a breaker right there. I usually always have a breaker or a fuse. If the controller's gonna fry, it's gonna fry anyway internally, and the fuse might not even help there. I was always doing this when I was a kid, like so close, a little bit more. It's brass, that's why I can do that. I want to strap this down because it's a big battery, so I don't want it going anywhere. Let's see if this thing works. So that's off over there. There we go. There it goes. All right, first test run. I've got the battery in. Everything is hooked up. I'm going to jump on this thing and I'm going to see if it works. I'm hoping that the wood will hold together, so let's get going. All right, so it's working. I changed out the sprocket and I've taken off the cassette and I just put on a single sprocket. All right, so it's faster now, 24, 25. That's not bad. Hardwood actually cracked. So I'm gonna have to reinforce this a little bit more. All right, so third time I've done a couple reinforcements. Okay, so it's working better. The chain seems to be holding on. It's going 25, 17 kilometers in. The maximum speed's about 25, that's it. But it's only 12 volts. It's actually working fairly well now. I'm hoping this chain will stay tight. The LiTime battery is working on this homemade e-bike. It's a little ridiculous, 100 amp hours, but it's working really well. But of course, it's only 12 volts, so I'm limited to what I can power with that. So I'm trying to keep an average speed of at least 20 kilometers an hour. Usually I just keep it full throttle, but of course the hills, they're really slowing me down. Almost 24 kilometers in. When I overvolted this motor, the bike used to do over 40 kilometers an hour. But of course, the motor and the wires and everything were getting really hot. Homemade 250 watt e-bike, and it's working. Okay, the range test is going to take me a while because I'm not going to be able to ride this in one day. So I've almost gone 41 kilometers and I have 72% battery left. So I've got tons of capacity left. That's full throttle, 30 amp draw, 28, 24, so it's dropping once, 19. Bike's working a lot better now. The chain is staying tight. I had to add shims and do a lot of tuning on this to get it to work, but it seems to be good now. I haven't charged the battery in days now, and we're 67 kilometers in. $90 kilometers in, still going. $99, 100 kilometers. I've gone 100 kilometers on the battery and I'm still going. So what I'm going to do is I'm going to pull over and I'm going to check the app and see how much capacity I have left. The crazy thing is I still have 31% left and I've gone 100 kilometers. Something, there's no way that these are just wild. Look at all these turkeys. All right, so I've gone almost 106 kilometers and I still have lots of battery life. So I'm down to 2%, so I don't think I'm going to be going very far. So I'm 135 kilometers in. That's it. So it started to slow down quite a bit, and then the BMS just cut out. I've run out of power, and I'm just checking the app here, so 0%. That was a lot of riding, almost 140 kilometers. So almost 85 miles I put onto this bike with the wood bracket. Not only am I impressed with the battery, but I can't believe the bike. Right now, the BMS is cut out. It might take a minute for the battery to actually turn back on. See, it's not kicking in yet. Okay, so this one's on lead acid. Let's try this one. Oh, there it goes. Yep. Okay, so now you can see it's at 1%. Some chargers don't seem to reactivate or turn on the battery because the battery needs to see a voltage. And there it goes. Inverter on. I'm in the back and I'm just going to camp out with the LiTime battery. So I want to see how many amps I can draw from the battery. So the hot plate is 1500 watts. So the hot plate can be used individually. So let's test the wattage of each element. The little element. Okay, 480 watts, 490 watts. And let's turn on the large. Okay, so that's the large one. It's 950 watts. Okay, so turn on the heater. Let's put the heater on high now. Let's see what high. Okay, so this is high, 56 amps. I've got the heater on, 37 amps, and then I'm gonna put on the element. Let's see what happens now. Okay, there's 75 amps. Okay, so what I wanna do is I wanna try now this large one. Let's see. 117 amps. Oh. 120 amps. So it's actually providing 120 amps right now. And the battery has not tripped out. That's really impressive. Okay, so they say that the battery can only provide 100 amps. Well, it's providing over 120 amps right now. As you can see here, 1,320 watts. 120 amps, and it has not cut out yet. Let's see if we can trip this thing out. There's 40. Let's try 1,500 watts and see what happens. 1,500 watts. Let's see. 14. 130 amps. 1,440 watts. Oh, it cut out. So the BMS cut out, but after about 30 seconds, the BMS reset. 940 watts, 81 amps. The water boiled very quickly. Yeah. Not only is the LiTime battery a great option for RVs and off-grid or solar setups, but it's also perfect for camping. Not only do I have enough capacity to cook, boil water, and run a heater, but I also have the app. So the app is really nice to have because it'll tell me exactly what amp hours I have left, and it'll tell me the wattage that I'm using. To get the full power out of the inverter, I would need another battery, and I would put them in parallel with each other. So this will be the battery I'll be taking camping with me all the time. So LiTime has another version of this battery. They actually have a trolling motor battery. Check out LiTime's electric boat conversion. They have the perfect setup. Convert any small boat or canoe or anything over to electric. This battery is a great option for me with the self-heating. If it's really, really cold out, then the battery can warm itself up and then it can start charging. Because if the battery drops in temperature, it can't be charged until it's warmed up. It's activated with 15-20 amp charger. Also, the battery can turn on the heating as well. There's basically heating elements or pads inside the battery. There's so many advantages to this lithium iron phosphate battery. Not only is the weight, also it can handle a high current charge, unlike a lead acid battery. But this one, I could pump 100 amps into it and charge it up very quickly. Like, the cycle life is the most important thing, even though the value might be a little higher on these batteries, but it's worth doing because the battery is going to outlast many lead acid batteries. After 4,000 cycles, the battery will still work. It just won't have the same capacity anymore. There's only one or two disadvantages between this battery and a lead acid. So this battery is not a start battery, can't draw more than 100 amps. So I'm not taking this battery apart, but other people have, and they actually have a good BMS and good cells in them, so that they are well made. So in conclusion, everything works on the battery. After testing, not only is the capacity of this battery perfect, I'm really happy with the capacity. The BMS works perfectly. The low voltage cut off. The high voltage charge cut off, and the high current cut out. The battery was going down the road on an e-bike, so it's been bounced around quite a bit. Everything on this battery is solid. Overall, a really nice battery from LiTime.